part is scalar quantities, scalar, and other is vector. Other is vector quantity. Firstly, we will discuss about what is the physical quantities. Physical quantities are those parameters which help to understanding the physics, like natural phenomena, because the physics is the study of the natural phenomena or some phenomena what occurs in the daily life. On basis of the physics, we know that the physical quantities are two types. I am telling you what is the physical quantity. Firstly, physical quantities are the parameters which help to understanding physics. Clearly here, if we want to understand physics or its phenomena, we have to know physical quantities. Two types of physical quantities are scalar quantities and vector quantities. So firstly, what is the scalar quantities? Scalar means scalar quantities. Scalar quantities means by the physical quantities which have only magnitude and no direction. We have need only magnitude of the quantity and no need direction is known as scalar quantities. For example, mass, time, temperature, distance, these are physical quantities such that to represent these quantities we have no need any types of direction. If we want to buy some potatoes from the market, we will tell him to give me 5 kgs of potatoes or 2 kgs of potatoes, and there is no requirement of the direction to telling the any physical quantity like mass. Similarly, if you want to know what is the time and somebody tells it's 10 o'clock, there is no requirement of direction. That's why this is also a scalar quantity. Temperature is also scalar because today, as we know that today is summer day. When the temperature rises 45 degrees centigrade, there is no requirement of any direction. We will tell about the temperature only, the explaining its degree, not direction. And similarly, if we will discuss about the distance, then there is no requirement of direction. If you want to measure the distance, like the length of this board or breadth of this board, then only need to explain here magnitude or number, numerical value, and no need of any direction. This is known as scalar quantities, and many more quantities which have no requirement of direction, known as scalar. Understand? In the same way, if you want to discuss about the vector quantities are those quantities to representing such type of quantities we have to also known direction as well as the magnitude. For example, I am telling you like force. If you want to understand the force, like if you push any book in this direction, we apply the force on this book, then we have to know the 5 Newton force is applied on the book in the east direction, in west direction or other way. Here, to two things are required to explaining any vector quantities. First is numeric value. Numeric value. Numeric value is also known as magnitude. Magnitude. And other is plus direction. Plus direction. While in the scalar quantities, we have only need to magnitude. Magnitude and no direction. Okay, this is the basic difference in vector and scalar quantities. And second example is that velocity. If you are explaining the velocity of any object, of moving object, then there is a requirement to full explain the velocity about the velocity of any obstacle, vehicle or any object. We will need here magnitude like 50 km per hour, 50 km per hour, because the unit of the velocity is kilometer per hour and meter per second or kilometer per hour plus direction in each direction. In each direction. Here we have the magnitude and the unit and also a direction. These quantities are known as vector quantities. Okay, and more difference is between scalar and vector. Here, scalar quantities represented a simply number and only magnitude, like 5 kg. It is a mass. Then we have known m equals to 5 kg. Okay. While if we will discuss about vector quantities like force, then we write here 5 Newton and represented by F and showing by a small arrow on the quantities notation. F bar or vector F. Okay. For showing representing a vector quantity, we have need to such type of notation, while in the scalar quantities only the alphabet can be written as. Okay. Now, if you want to add the scalar quantities like 35 degrees centigrade plus 2 degrees centigrade, we know that we found here. Sorry, it will take the other example. The reason is behind that is I will discuss about sometime. But here, if you want to add 4 degrees centigrade plus 3 degrees centigrade becomes 7 degrees centigrade. Okay. Simply we will apply the addition, and if you want to subtract 4 degrees centigrade minus 3 degrees centigrade, we know that we found 1 degree centigrade. Okay, this is the simple operations of addition and subtraction. And also 4 degrees centigrade multiplied by 3 degrees centigrade, we will get 12 degrees centigrade. And if you will divide 4 degrees centigrade divided by 3 degrees centigrade, and we know that 4 by 3 degrees centigrade, so that the 4 operations are there: addition, subtraction and multiplication, and now division. But in the case of vector quantities, we do not apply such type of operation directly. Like if on any body 4 Newton force is applied on this direction and 3 Newton force applied down direction, then the resultant force on this object is not 7 Newton. Here the resultant is what? This is 4 Newton and this is 3 Newton. The resultant is 5 Newton in this direction. Why 5 Newton? Here is a right angle triangle. This is 3 and this is 4, and now this is also 4. 4, perpendicular is 4, base is 4, then hypotenuse will be 5 Newton. This is the basic difference. Now again, firstly we will discuss about vector. Vector is represented by any arrow. If we represent 5 Newton force in east-west direction, then we will write here 5 centimeter arrow or 5 mm arrow. Okay, the 5 Newton is represented by such type. Why? The length of the arrow denotes the magnitude of this quantity, that quantity, and the tip of the arrow denotes the direction of that quantity. Similarly, if we denote any velocity or acceleration or torque or momentum, these are all vector quantities. We will apply such this types of rule, arrow method. 3 meter per second we will represent it by in downwards. Then we represent it here 3 centimeter of arrow and downwards. The direction is represented by this tip of the arrow and the magnitude is represented by length of the arrow. This is the representation of vector quantities. Sorry. Okay. Now, this is the difference. Scalar quantities we have discussed in previous classes also, but in the class 11 only we will discuss about the vector quantities. The representation of the vector quantities is I am showing you, and the operations also we will discuss here. So, if the video is helpful, you can like and subscribe this channel. Now, the operation of the vector quantities are represented like any such. A is a vector quantity written as 2i cap plus 3j cap plus 5k cap. And other is B is I cap minus 5j cap and plus 3k cap. These are two vector quantities. I cap, j cap and k cap are the unit vector along the x direction, y direction and z direction respectively. We know that this is x axis and this is y axis and this is also z axis. In the x direction, the unit vector is represented by I cap, and in y direction denoted by j cap, and in z direction denoted by k cap. I, j, k are the unit vector along x direction, y direction and z direction respectively. The magnitude of the I cap, j cap and k cap are unity, 1. This is also 1 and this is also 1. Okay. If any vector denoted by A vector 2i cap plus 3j cap plus 5k cap, it means that the component of vector A along the x direction is 2 units and along y direction is 3 units and along z direction is 5 units. Similarly, vector B denoted another vector. The component of B vector along x direction is 1 unit and along minus y direction is 5 units and along z direction is 3 units. If we want to add the type of vector or subtract, we apply simply method like algebraic addition and subtraction. Vector A plus vector B can be added by similarly 2i plus 1i become 3i, 3j minus 5k become minus 2j cap, and 5k 3k is represented by 8k cap. 8k cap. Understand? Similarly, we have to apply for subtraction. We will get here, if we subtract 1i from 2i, we get I cap, and 5j subtracted from 3j, we get minus minus become plus, and we get 8j cap. Similarly, 5k minus 3k, we get 2k. This is the addition of the two vector quantities. Similarly, if you want to product of these vectors, you know that vector A and producted by vector B denote by two ways, A dot B and A cross B. This is the important thing for the class 11 and also competition examinations. There are two types of product. Addition and subtraction is similar as an algebraic expression. But in the product, we have two ways to define the product of the vector quantities. First is dot product known as scalar product and cross product known as vector product. Both are the difference from each other. If we want to scalar product of these quantities, similarly we have to write here 2i cap plus 3j cap plus 5k cap and dot second vector is I cap minus 5j cap plus 3k cap. And taking the vector, firstly we know that the formula of A dot B is AB cos theta. What is the AB? AB is the magnitude of the vector A and vector B respectively, and theta is the angle between them. Like this is vector A and this is vector B, then the theta is the angle between these two vectors. Then the product of A and B is written as A dot B scalar product. The scalar product written as A dot B equals to AB cos theta. A is the magnitude of A and B is the magnitude of B, and theta is the angle between them. Similarly, if you apply for I dot I. So I dot I, the angle between I to I is 0. Then here we get 1 into 1 because magnitude of the I is 1 and I is also 1, and angle between them is 0, cos 0. Cos 0 becomes 1, then we get only 1. I dot I is 1. Similarly, we can write here J dot J is also 1 and K dot K is also 1. In the second way, I dot J. What comes I dot J? Because angle between I and J is 90 degree and cos 90 is 0, then we have right here I dot J is 0 and J dot K is 0 and K dot I is 0. In the summary of the topic, we can say the same dot product of same vector is 1 and is one what? Unit for unit vector, and the different vector is 0. Similarly, for cross product, the formula is what? A cross B or A vector product with B, we get A B sin theta n cap, where A and B are the magnitude of the vector A and B, and theta is the angle between them. If we want to vector product between A and B, we write here AB sin theta n cap, where n cap represents the direction of the product. यानी जो इनका result आएगा, sorry, the direction of the resultant vector denoted by n cap, यानी n cap right here. We can say about the n cap, it is the unit vector along the product, along the resultant vector. Okay. Then I cross I becomes what? The angle between I cross I into I is 0 and sin 0 is 0. Then we get I cross I is 0 and J cross J is 0 and K cross K is 0. The cross product of same unit vector becomes 0 and cross product of I cross J become K. I cross J become K and J cross K become I and K cross I become J. We want to understand this is very important for the vector product or two vectors. I dot J, I will repeat here, I cross J is K vector, J cross K is I vector and K cross I is J. It is clockwise. Here I, J and this is K. Then I cross J is K, J cross K is I and K cross I is J. But if you move anti-clockwise, here we get the results are negatives. And I dot J, sorry, I cross K become minus J. K cross J become minus I. Similar. Now, the product of these quantities can written as we know that the dot product of same unit vector become 1. That's why 2i will multiply by I become I become 1 and we get only 2. While if you multiply I with j, we get 0 because the dot product of different vector is 0. Thus, I cross j is 0 and I cross k is 0. Plus, now 3j is multiplied by I becomes 0 and 3j become multiplied by 5, we get 50 minus 15. Minus 15 only because j dot j is 0. Sorry, j dot j is 1. Sorry. Similarly, 5k multiplied by 3k, sorry, 5k multiplied by 3k, we get 15 and k dot k become 1 and no need to multiply other steps, other coefficients because the multiply of the dot product of 5k with I becomes 0 and 5k with 5j becomes 0. That's why our result arrives 15 cancel out, we get only 2. The dot product of A and B, we will get 2 only because it is a dot product and it has no need of direction in I, J, K. This is the dot product or scalar product. If you want to try vector product of these quantities, we have the matrix method to multiply such type of vectors. I want to erase some values here. Yes, I want to just vector product of these quantities or these vectors. When we have right here A vector cross B vector. Okay, the vector product is represented by cross product, and the matrix method is that we write here I, J, and K. The coefficient of vector A is 2, 3, 5 and 1 minus 5 and 3. For solving the matrix, we get the result of A cross B and a cross product of two vectors. How? Let me see. I, the coefficient of I is what I row and column is blocked, and we get 3 3 are 9 minus 5 5 are 25 or minus become 25 plus. And now with minus j, we will take minus row of the j and column of the j, and coefficient of this is 2 3 are 6 minus 1 5 are 5 and plus k. Coefficient of k rise, we remove, we left column of k and column of row of k, and we will get 5 to the 10 minus times 10 and 3 1 are 3 minus 3. And also by solving this relation, we will 29 I cap, 29 no 25 and 34 I cap minus 1 j cap, we have not need to write here 1, and minus 10 minus 3 minus 13 k cap, minus 13 k cap. This is the vector product of two quantities A cross B. A cross. Thus we can solve the problems on the basis of this examples. Addition and subtraction I will discuss in previous time, and this is the vector product, and before this we will discuss, we have to discuss about dot product or scalar product. In next class we will try to next lecture about the vector